Okay guys, in this video we're going to take this idea of atomic mass and moles and combine the two together. So we are able to take moles of something and use the atomic mass off the periodic table to solve for more complex compounds. Okay, so we already know that if you take the atomic mass of something, that is related to the grams in moles. Okay, in our last video we talked about how aluminum has an atomic mass of 26.98 AMUs, so that was the same as 26.98 grams per mole. Okay, so let's apply that concept to when we have compounds like sodium chloride or carbon dioxide. How do we combine these together when we get more than one atom? Okay, when we do that, we call it a molar mass instead. We're still using molar mass and we're still saying grams per mole. That's not changed. So all we need to do when we deal with the compound is add up the atomic masses to get a total molar mass. Okay. So let's do a practice problem to see what I'm talking about here. So if I have sodium carbonate and I want to know the grams of sodium carbonate in a mole of it, or the molar mass of sodium carbonate, we want to break that down. So let's go to the board and do that. So first thing we need to do is we know we have sodium carbonate. And sodium, I need two of these because carbonate's a -2, it's a 1+. So I have sodium, I have carbon, and I have oxygen. Sodium, I have 2 of them. Carbon, I have 1 of them. Oxygen, I have 3 of them. I'm going to take how many I have of each one and multiply it by their atomic masses. Okay, so sodium's atomic mass, if we look it up, is 22.99 grams per mole. Carbon's atomic mass is 12.01 grams per mole. And oxygen, it's 15.9994 something grams per mole. Now, every periodic table is slightly different in terms of the precision they report atomic masses to. So what I do, and I'd like you to do, is anytime you use a number off the periodic table as atomic mass, we're going to purposefully round it to the hundreds place. That way we're all using the same precision no matter what source of periodic table we're using. Okay? So that being said, it does something really nice for oxygen, and we can treat oxygen as 16 grams per mole at all times. Now I have all these. I'm just going to add them up. So 22 times 22.99 is 45.98 grams per mole. This is still 12.01 grams per mole. 16 times 3 is 48.00 grams per mole. Now I add them all together, and that adds up to being 105.99 grams per mole. Or we're saying that for every 1 mole of sodium carbonate, it's 105.99 grams are going to be inside that. Okay? Or we say its molar mass is 105.99 grams per mole. Okay? So if we take a look, and sure enough, see the same math, we get the right answer. That's our molar mass. Molar mass is one of the most important mathematical tools that we use in chemistry. Okay? We'll be doing molar masses for the rest of the year. In fact, you're going to get so good at them that by the end of the year, you're not going to even think about molar mass as a problem to do. It's just going to be one step in a much bigger, more complex, more fun thing to do. Okay? Now, we have 2 more. We have lead 2 nitrate here and bromine. These you can do on your own for additional practice. Be careful of bromine because bromine's a diatomic. Okay? And then lead 2 nitrate, make sure you get your formula right before you solve for that. Okay? So you can do those on your own. What I want to do is take this idea of molar mass and now apply it to how we can utilize it with grams and moles. Okay? So to do that, we want to have a relationship between moles and mass. Okay? So if we know the molar mass of something, we can actually convert from moles to grams pretty easily, or from grams to moles. So these are 2 practice problems doing a very simple conversion. Okay? So let's take a look at the first problem. So how many grams are in 3.45 times 10 to the -3 moles of potassium nitrate? Okay? So our first step in this process is to set up a simple conversion. So we have 3.45 times 10 -3 moles. And we want grams. And we're dealing with potassium nitrate. Now potassium nitrate is KNO3. So to do this, we have 1 potassium, we have 1 nitrate, and we have 3 oxygens, okay? So potassium, if we look it up, it has an atomic mass of 39.10 grams per mole. Nitrogen is 14.01 grams per mole. And oxygen, again, is 16.00 grams per mole. Okay? And if we take this, and we have our 39 plus 1401 plus 16 times 3, and if we add those all up, we get a molar mass of 101.11 grams per mole. So adding these all up, factoring the 3 here, is 101.11 grams per mole. Which means if I have 3.45 times 10 to the negative 3 moles, for every 1 mole, I have 101.11 grams of my potassium nitrate. So moles can cancel, and I would take the 3.45 times 10 to the negative 3 times that, and that will tell us our grams. Okay? If we do this math, we end up getting 0.349 grams, rounded to 3 layers of precision, because this has 3 layers of precision in it. Okay? So if we go back to the screen and we check it, and sure enough, we end up with 0.349 grams of potassium nitrate. Okay? We can do the exact same thing for our next problem, but in this case, we want to know how many moles are in 2.23 grams of magnesium chlorate. Okay? So in this case, we know the grams of magnesium chlorate and we're solving for moles. So in this case, our grams will be on the bottom and our moles will be on the top. So when you solve for the molar mass of magnesium chlorate, okay, we're going to put the grams on the bottom and the moles on top, so we're going to flip it, okay? So I'm not going to go through all the math again for molar mass, I'm just going to tell you that one. So magnesium chlorate is 191.21 grams per mole, okay? So it's 191.21 grams per mole if you solve for that, okay? You know you have 2.23 grams, now you divide by 191.21, and if you do that, you get an answer of 0.0117 moles of magnesium chlorate. Okay? Go back to our screen and we see it worked out there also for you. Okay? So this is a very simple one-step process, but when you're working with moles of mass, this one step is probably the most common step that you're going to do in all of our problems coming up in this unit. Okay? Is being able to go from moles to grams or grams back to moles. All right, guys, I'm going to end the video here. Tomorrow we'll go back into and start doing more with mole ratios. Thank you.